Hello everyone, my name is Vincent and Wijaya. I'm from Indonesia, and today I will be presenting about my Codeavour project. The title of this project is Intelligent Driving Pedestrian Detection System based on machine learning. My competition theme for this project is Make Smart Transportation Systems. So why do I choose this topic? I believe that smart transport systems worldwide are working towards enhancing the safety and quality of life for everyone in urban areas. Overall, intelligent mobility's main benefits include better safety, accessibility, and sustainability of transportation systems. Pedestrian detection. Pedestrian detection is a specific application of object detection. Compared with general object detection, it shows similarities and unique characteristics. In addition, it has important application value in the fields of intelligent driving and security monitoring. In recent years, with the rapid development of deep learning, pedestrian detection technology has also made great progress. However, there still exists a huge gap between it and human perception. Meanwhile, there are still a lot of problems, and there remains a lot of room for research regarding the application of pedestrian detection in intelligent driving technology. It is of necessity to ensure its real-time performance. Additionally, it is necessary to lighten the model while ensuring detection accuracy. Introduction. Object detection is a basic problem of machine vision and deep learning, and it lays the basis for the in-depth development of numerous research problems, including instance segmentation, trajectory prediction, and image reconstruction. Pedestrian detection is a specific application of the object detection problem, and it has become one of the research hotspots in recent years. It has important application value in the fields of intelligent driving and security monitoring, particularly in the field of intelligent driving. Due to the particularity of people and the highest safety requirements, it is more important than other types of object detection. In intelligent driving, the camera, lidar, and wireless sensor network jointly perceive the environment and further employ vehicle-mounted computers and cloud computing to make decisions and control. Pedestrian detection method based on deep learning. The task of pedestrian detection has officially entered the deep learning stage. In general, detection methods based on deep learning mainly consist of two categories. One is a two-stage processing method. Firstly, regional suggestion boxes for possible objects are generated, and then further predictions are made on these suggestion boxes. The other is a one-stage processing method, which directly returns the object area on the feature map and gives the final prediction result. Dataset and evaluation method. The dataset is the basis of the pedestrian detection task. It not only is a data source for researchers to conduct experimental tests, but also provides the same databases for the performance comparison of different algorithms. Measuring the quality of a dataset includes the amount of data and the quality of labeled information. Thank you. Now we will proceed to the demo of my project. Okay, so this is my project that I've opened in PictoBlocks. So first off, I will tell you how my code works, and I'll be using the machine learning environment extension, which you can find here. It's this one right here. So first off, you will open this menu, and there will be one option here, which is the open machine learning environment. So I click it here. So the way I make this project is I create new project, and then I'll type the name. The description is optional, I didn't type it, and then I will choose this object detection. Since I already have it, I'll go back to my project here. So I'll just click it. So this is my machine learning samples and also the training. So first I'll explain on how the machine learning identify these samples and classify them as a children, man or woman. So I'll be having three classes. Uh, I'll explain how they classify and see the characteristics from the children, man, and woman. So for children, the machine learning will identify whether or not uh, they are a little bit shorter than the normal man or woman, and then they might be wearing school clothes, or maybe they have friends along with them. Maybe they're going to school, so there's a school bus right here. Maybe they're crossing the road with their friends, and then whether or not um, they're with parents or not. But it seems like I didn't put any parent pictures here, so there's only students here. And so I didn't specifically make them so that it can identify the men, the boys or girls. So I'll just be having the children samples here. So to find my children samples, the keyword for looking at the children samples is children on the sidewalk. As you can see here, I take samples from Google. As you can see here, there's some children here walking on the road. Maybe they can also draw stuff here, like this example here. Maybe they can walk alone here. So most of all, I choose pictures like these, which only consist of one or two children, so that the machine will understand it immediately. I'll also be using images that contain a car or motorcycle, and they're on the sidewalk of the road, and that there's activities such as the car moving or another transportation, or they could also be riding bikes on the side road. Okay, so next I'll be telling you how they classify these men pictures right here. So the men has some characteristics such as they may wear business attire, such as they're wearing these formal suits and formal jeans, trousers. Maybe they're also wearing glasses, and that they have short hairs, and maybe they're wearing formal shoes, such as those white shoes or black shoes, usually where they go to work. And then you can see I have a lot of pictures of them near the road, and that they're walking, maybe near a car. So the keyword for find man pictures, I'll be using man on the sidewalk. So basically, I just took these pictures right here, but most of all, I took the pictures on their full body, and as well as some cars in the background, so that the machine learning will understand that this is a man. This is what it looks like. So it could also detect whether or not they have colored hair or not, and also whether or not they're walking on the sidewalk, and maybe they have a friend along with them, and then there's some cars in the background or motorcycles to make more of a scenario that they're on the sidewalks. So next, I'll be explaining the characteristics of a woman. So they may wear business attire such as maybe a coat, maybe a shirt in the insides of the coats, maybe jeans or trousers as well, maybe boots, and they have long hairs or usually medium size hair, which is uh reaching their elbows. And my samples here contain that they're walking on the road on the sidewalk. As you can see here, there's some cars behind there, a motorcycle as well. So the keyword for finding these pictures are woman on the sidewalk. So as you can see here, these pictures show that they're walking the sidewalk and that there's cars and transportation behind them to further uh, give machine learning image that they're walking on the side of the road. They might also bring a friend walking with them, and mostly I took pictures of them being alone, walking alone, or with their friends, but not the one that has the men in them. So I'll just take the pictures, only the woman walking on the streets. So I'll be also using the cars in the background here. For example, like these. This example of the woman walking on the sidewalks, maybe crossing the street as well. I'll take that as well. And then maybe also carrying a stroller. I'll put the images on my samples, and that will detect this one right here. Maybe they're not wearing their business attire, such as like this as well. And maybe they're just taking a photo, maybe. I'll include that as well. So yeah, this is my training. It's a 0.8 successful rate, so it's pretty good as I say. For me, I think it's probably pretty accurate. For the advanced settings, I set my epoch settings to 50 so that it will read the image 50 times per image and that it will be more accurate. So the more the epoch sizes, the more accurate it will be. Alright, let's go back to my project. So this is my project here. So when I run it, there's two options here. It's my info. It's basically my info right here. And to run the program, you simply just click this button right here. So this is my sprite. My sprite will identify, as you can see from the script, the code, block code. So when I see this play button, which is the play button before I made it, and then there will be a play button that which you can press, and it will broadcast the message play. And here the block code will be when I receive play. It will be in a forever loop and then analyze image from of course the stage. Change this as well, but I prefer the stage because I uploaded the backdrops as the stage. And then my sprite will say the identified class for 2 seconds. 2 seconds here can be longer if I want to change it. And when it's done detecting, it will search the backdrops. So as you can see, it's working pretty fine. It's children, that's a man. It's another man. It's children. Children. I have 6 backdrops here and 2 for each one. So here you go, that's one right here. So 2 children's, 2 men's, 2 women's. And as you can see, they're on a street. As can be seen here, they can be walking on the sidewalks here, or they could be crossing, or they could be facing back. They're not. There's still some details on the back, which is like traffics, maybe cars, transportation systems. Maybe they're using a bike, or maybe they're just crossing the road. And when I click this back button, it will simply stop the script. So that's my project. Thank you for listening. Goodbye.